welcome to the deep dive. Today we're looking at something pretty interesting, how extreme weather really tests renewable energy, specifically solar. And we're focusing on Nebraska. It's got this unique climate, lots of challenges, but it's also becoming, well, a real hub for solar innovation. So this deep dive is about exploring some cutting-edge tech. People are calling it rain-powered solar. The idea is generating energy even when it's pouring, not shining. We've looked through, quite a few sources, research papers, real-world examples from Nebraska itself. Our goal here, to pull out the key insights, the surprising bits about how Nebraska is really pushing forward with renewables. Okay, let's get into it. So first up, what's the solar situation in Nebraska right now?
They're building more capacity, right? Like that community solar project near Scottsbluff. It's pretty big, 4.375 megawatts AC.
Yeah, that's a significant installation, over 13,000 modules. And what's really notable is the power purchase agreement rate.
It's low, isn't it? Like 0.051 times per kilowatt hour.
Exactly.
Yeah.
Which sounds incredibly cheap.
Yeah.
But what's fascinating and challenging is the context there.
Yeah. Well, the average cost for electricity consumers in Nebraska is already pretty low, around 8 cents per kilowatt hour.
Ah, okay. So not a huge price difference then.
Right. That narrow gap makes the return on investment slower. And then you add in Nebraska's weather, frequent hailstorms, sometimes, baseball-sized hail.
Baseball-sized? Wow. That must wreck the panels.
It certainly can. So you've got this double whammy, significant physical risk from hail, and slower economic returns. It really creates this unique pressure cooker for innovation.
So facing those kinds of hurdles, what are the breakthroughs? You mentioned rain-powered solar, Triboelectric nanogenerators, TENGs. How on earth does rain make electricity?
Yeah, it sounds a bit like science fiction, doesn't it? But TENs are, well, they're very real. Think of it like harvesting static electricity, basically.
Okay.
They convert mechanical energy, like the impact or friction of a raindrop hitting a surface, into electrical energy.
So you put these TENGs on a solar panel.
Exactly, as a transparent layer on top. When rain hits, the TEN layer harvests energy from those impacts through something called triboelectrification.
Huh. So friction from raindrops.
Pretty much. Now, one drop isn't much power, obviously, but think about a whole rain shower.
Right. Thousands, millions of drops.
Exactly. The cumulative effect can actually be quite significant. It means the panel could keep producing some power even when the sun's completely blocked by rain clouds.
Which is when a normal solar panel produces nothing.
Precisely. And researchers like those at Tsinghua University have already figured out how to link lots of these tiny droplet TENGs together, kind of like solar cells in a panel.
Okay, that's the tech. But let's bring it back to Nebraska. That Scottsbluff farm you mentioned earlier,
Yeah.
It actually got hit by that kind of hail, didn't it?
It did. In June 2023, a really severe storm, baseball-sized hail, significant damage. It even made national news.
So did it prove that solar just isn't viable there?
Actually, no. Quite the opposite in a way. It highlighted the resilience. Yes, the damage was bad, but the farm was fully repaired and back online by January 2024.
That's pretty quick, considering.
It is. But it also underlines why developing tougher, maybe even hybrid technologies like these 10G integrated panels is so important for places prone to extreme weather. It shows solar is viable, but we need to make it even more robust.
So weighing the options. Traditional solar is cheaper initially, but these 10 hybrids, they might perform better overall in places like Nebraska.
That's the potential, yes. Better all-weather performance. But technology isn't the only piece of the puzzle in Nebraska.
What else is going on?
Well, there are social and political factors. You see some significant rural opposition to building large solar farms.
What's concerns about farmland?
That's often the core issue, yeah.
Okay.
Using agricultural land for energy generation, it's led to some local counties actually putting ordinances in place to block new solar developments.
So that creates a real dilemma. How do you balance the need for clean energy with protecting agriculture, which is obviously vital for Nebraska?
It's a key question.
Yeah.
But there are solutions being explored, things like agrivoltaics.
Agrivoltaics.
Yeah, where you elevate the solar panels high enough off the ground so you can still farm or graze livestock underneath them. Makes the land dual use.
Okay, that's clever.
Or simply using less controversial spaces, like putting large solar canopies over parking lots. And think about integrating these technologies. If you have panels that can generate from sun and rain using TENs, maybe you could even design them to channel and collect the rainwater, too. Multifunctional
So
systems.
energy and water harvesting from the same installation. That could be huge, especially for farming communities.
Exactly.
It really seems like Nebraska's situation, these tough conditions, they're not just problems. They're actually driving innovation, maybe faster than might happen elsewhere.
I think that's right. These challenges are forcing the development of more resilient, more integrated solutions. It's pushing the technology forward, which leads to a bigger thought, really. These multifunctional systems, sun, rain, maybe water collection, they feel transformative. It really makes you wonder, doesn't it? How could these integrated approaches change renewable energy in other difficult climates, all around the world, not just Nebraska?
That's a great point to ponder, how lessons learned in one challenging place could unlock potential everywhere else.
Well, thank you for joining us on this deep dive into rain-powered solar and Nebraska's journey. We hope you feel a little more well-informed.